I will be now solving this question for you. This is again from the partial fraction decomposition lesson. So for partial composition lesson, now the top is small degree than the bottom. That's a good thing. So we don't have to do the long division first, but we still have to factor the denominator. So x cubed minus 4x squared plus 5x minus 2. I need to factor this. Now, we teach this in Algebra 2 about finding the factors of this polynomial, but there is one theorem says that the possible solutions for this polynomial will be, if you look at the factors of the last number and factors of the first number and look at their ratio, those are the candidates. So what I'm going to see is if 2 is a solution. In order to check if 2 is a solution, I mentally plugged in 2 for x. So when I plug in 2 for x, 2 cubed, and then 2 squared times -4, 5 times 2 minus 2, I will check if this gives me a 0. And in fact, when I plug in 2 for x, it does give me a 0, which means that 2 will be a 0 for this solution. And if you evaluate this, this will be a 0. If 2 is a solution, I know that one of the factor is x minus 2. One of the factor is x minus 2. If I already found one of the factors, I can perform synthetic division to find the other zeros. I have 1x cubed, -4x squared, +5x, and -2. I know that 2 is going to already work for them, so I'm going to divide them by 2 to reduce the degree of this polynomial. Bring down the first one, multiply 1 by 2, which becomes 2, add them up. Multiply -2 by 2, which makes -4, add them up. 1 times 2 is 2, add them up 0. So this is called a depressed polynomial. So I have 1x squared minus 2x plus 1 to factor now, which is a very easy factoring. If I multiply -1 by -1, it gives me a +1. And when I add them up, their sum is -2. So the factors are here, x minus 1 times x minus 1, which I can just write as x minus 1 to the second power. So all this work so far is this question that they want us to do partial fraction. Its numerator is -x squared, and its denominator is one factor is x minus 2. We just guessed this and it worked. And then after guessing this, I did the synthetic division and found the other two factors, x minus 1 to the second power. Now, if we remember the template for this kind of denominator, we'll need a over the first factor plus b over x minus 1, and then c over x minus 1 squared. This is the template I need for partial decomposition. So I'm going to scroll down a little bit, get more room. I think what I can do is, because I want to remember all this when I go to the next page, I want to just cut it again. And then I want to paste it on the next page where I see more room. Or you can start pasting from here. So once we decide the template we're going to use, all right, we know that now we have to get them all in common denominator so we can cancel the denominator. So x minus 2 times x minus 1 squared is the common denominator for all of these fractions. This one has already x minus 2, so it needs x minus 1 to the second power. This one has just one x minus 1, so it needs one more x minus 1, and it also needs x minus 2. The other one has x minus 1 squared, so we just need to multiply it by x minus 2, which means this is going to stay the same, -2x squared over x minus 2, and x minus 1 squared is going to stay the same. But over here, we will multiply top and bottom, so I will get a times x minus 1 squared over x minus 2 times x minus 1 squared, plus here I'll get b times x minus 1 times x minus 2. And the common denominator is now x minus 2 and x minus 1 squared. And on the last one, if I multiply top and bottom, I'll get c times x minus 2 over x minus 2 times x minus 1 squared. After I got this, now all the same denominators, we can cancel them. So I have just negative 2x squared here on the first side. On the right side, I have a times x minus 1 squared plus b times x minus 1 times x minus 2 and c times x minus 2. Now, if we choose x to be 2, the reason I wanted to choose 2, when I plug in 2 minus 2, c will cancel. I have a 2 minus 2 here, which will cancel the b. So if I plug in a 2, I get negative 2 times 2 squared is equal to a times, I'm going to also have to plug in 2 here, 2 minus 1 squared. This is going to directly give me the value for a. 2 squared is 4, negative 2 times 4 is negative 8, is equal to, and this is 1, just 1. So a must be a negative 8. And that's how I can find the a value. Now, if we let x to be 1, when I plug in 1 for x, then the a will disappear from the equation, and b will disappear because b depends on x minus 1. So the only thing that's going to stay is now c. So we're going to plug in 1 here to the entire equation. Negative 2 times 1 squared is equal to c times 1 minus 2. That's a negative 1c, and that's a negative 2. When I organize it, that makes my c value to be positive 2, right? So we use 2 and 1, both of it. Now I can use the real values for a and c now to organize my equation. Now I'm going to scroll down a little bit more. So what I have now is negative 2x squared is equal to, I don't have to keep this a anymore. A is negative 8, x minus 1 squared. Plus, we still don't know what b is. B times x minus 1 times x minus 2. And instead of c, we can plug in a 2, 2 times x minus 2. So we're going to organize the right side. We're going to simplify as much as possible. Then we will match the coefficients from the left side. So I have negative 8. And I expand this. It gives me x squared minus 2x plus 1. This one, I will have to still multiply by b, but x squared, that's a negative 2x. That's negative 1x, total negative 3x. And this is plus 2. And then this is 2x minus 4. So that makes a negative 8x squared. So negative 8x squared here. And then we also have the bx squared here. So total this many x squared on the right side. Similarly, negative 8 times negative 2 is plus 16x. So that's a plus 16x. And then this one is b times negative 3x. That's negative 3bx. And then I have plus 2x here. All of these are the coefficients for x. And then the last thing I have is negative 8 times 1 is negative 8. And then here b times 2 is 2b. And then I have a negative 4 as a constant. And then they're all equal to a negative 2. We're going to organize this more to find the value for b. So this is negative 2x squared. So negative 2x squared is equal to, we have negative 8 plus bx squared. Here, 16 plus 2 is 18. 18 minus 3bx. And then here, negative 8 and negative 4, when we combine them, that's negative 12 plus 2b. Now, the easiest one for me is now match this with a 0. So if you look at the first side has only an x squared term. It doesn't have an x term. It doesn't have a constant. So the constant I see on the right side, negative 12 plus 2b, is just a 0 on the first side. This is going to help me to solve for the b. B must be 6 if this equation is equal to 0. So I just figured out the value for b. But we can double check here. So since there is no more x here, 18 minus 3 times 6 is also 18. 18 minus 18 is 0 times x. That also clears out the x value on the left side. If we plug in 6 here, negative 8 plus 6 is negative 2, and that's equal to a negative 2x squared. So b must be equal to 6. Now, we already got the A value at the top. A was equal to -8. Now we know that B is 6, and then C, we got it as -2, I believe, on the +2 on the top. So the expected answer will be here. That's the C value. So the expected answer will be -8 over, and then 6 over, 2 over. I just need to remember the denominators. We gave them at the top. A got x minus 2. And this one got x minus 1. And this one gets x minus 1 squared. And this will be the partial decomposition for this question.